The first video of the next unit is going to give us a lot of specific things that we can talk about with a quadratic. So what we're going to look at today is a whole lot of parabolas. Now, in the last unit when we talked about parent functions, we talked about some very basic things like parabolas can be moved left or right, up and down, things like that. Now, the thing that had to be required about that is that every single one of them had to be in the form where something looked like this. And so you had a parenthesis squared with a number inside with x and a number on the outside, added or subtracted. Now, not all quadratic equations are going to look like this. Sometimes you get a quadratic in what's called standard form. So we're going to look at standard form, and that would be something like this equation here. Y equals ax squared plus bx plus c. So if I actually plugged numbers into that, it'd be something that looks like 2x squared minus 4x and a plus 8, for example. So this is called standard form. This is actually called vertex form. Vertex form is something that I'm going to talk about when I flip this current page. So right now, everything I'm talking about here is about standard form. Now, certain structural parts of a quadratic, number one, it's a U shape, and we all know that. The other thing that is true about a quadratic is that it's symmetric. Its symmetry isn't always around an axis. Sometimes it's around a random vertical line. So sometimes, or something like this one. So this particular quadratic is the exact same thing on the left as it is on the right. The line that cuts it in half is called the axis of symmetry. And that axis of symmetry is just a vertical line in the form x equals a number. So looking at this line crosses through the x-axis at -2. So that axis of symmetry in this picture would be the line x equals -2. The other structural part of a parabola is its vertex. It either has a very low point or a very high point. It won't have both. So this vertex has just a coordinate point. It's the very bottom point of the parabola. This one is at the coordinate -2, -3. So that is called the vertex, the very bottom point. Now what you should notice is that the x-coordinate of the vertex is the exact same number as the axis of symmetry. That will always happen. The x-coordinate of the vertex will always be the same as the axis of symmetry. So what do I do if I have a quadratic? What steps should you follow in order to solve or to graph it? The first thing you're going to do, you're going to find the axis of symmetry. That's going to be found by using this nifty little equation, -b over 2a. So what do a and b stand for? They are the numbers in front of x squared and x. The number in front of x squared is the a. The number in front of x is the b. So this says that the axis of symmetry would be at the opposite of b. In this case, b is -4, so I would use +4, over 2 times a. A is 2, so I would do 2 times 2. You would simplify that fraction. 4 over 4 gives me an axis of symmetry at 1, which means that on my graph, I would have a vertical line that's going to cut my parabola into 2 mirror images, and that line would be at +1. Once you have this value, what's the next step? The next step is to plot the vertex. What you're going to do is take the value you just found, and that is the x-coordinate of your vertex. In order to find the y-coordinate, you do what you do for any coordinate point. If you know the x, plug the x into the equation, and that'll give you the y-coordinate. So in this case, if 1 is the x-coordinate, I'm going to plug that in for x. So we do 2 times 1 squared minus 4 times 1 plus 8. And my job is to simplify. This first part is going to give me 2. Second part, -4 plus 8. If we simplify that, we have a 2 minus 4 and a plus 8. So that's going to give me a total of 6. That would be your y-coordinate of your vertex. So that means on this parabola, either the very bottom point or the very top point would be at 1, 6. How do you determine whether you have a very low point or a very high point? This number in front tells you whether your parabola is going to turn right side up, like that, or if it's going to turn upside down, like that. So if your a value is bigger than 0, so if it's positive, you're going to turn right side up. If that a value is less than 0, you're going to turn upside down. So in this particular case, since that 2 is a number bigger than 0, this one is going to turn right side up, which means that that vertex point is going to be the very bottom point of the parabola. Once you've figured out what the vertex is, you're going to make an XY table, plot enough necessary points, use a little bit of symmetry, and connect the dots. So let's work through a whole problem together so you can see what all the steps look like put together. So the first problem here is a quadratic in standard form. So the first thing I'm going to do with this quadratic is find the axis of symmetry. So x equals negative b over 2a. B in this case is positive 4, so we're going to do 4, its opposite, over 2 times a, so 2 times 2. Simplifying that's going to give me negative 4 over 4, which gives me an axis of symmetry at negative 1. So that means on my graph, I'm going to have a vertical line that goes right through negative 1, and I'm going to dash it right down through the center of negative 1. Once I found the axis of symmetry, the next thing you would want to do is figure out the vertex. That vertex is going to have an x-coordinate that's the same as the number you just found. Your job is to find the y-coordinate by plugging it in. So I would have 2 times negative 1 squared plus 4 times negative 1 and subtract 1. Now every time you're doing these evaluations, do you need to write out the evaluation and plugging in every time? No. Use your nifty calculator. So that's exactly what I'm going to do. So I'm going to type in exactly what I just wrote down. 2 times negative 1 squared. Then we're going to do 4 times negative 1. And then we're subtracting 1. And that will give me my x or my y coordinate of negative 3. So this quadratic is going to have a bottom point at negative 1, negative 3. So I'm going to go ahead and put that on the graph. And then all I have to do from here on out is plot some XY chart tables. So the nice thing about XY charts is I can pick any numbers I want. So the numbers that you want to pick 2 more numbers. You want to pick them on the X column. And you want to make sure that you pick numbers that are on the same side of the axis of symmetry. So in this case, since my axis is at negative 1, I'm going to choose x values of 0 and 1. I could have also chosen x values of negative 2 and negative 3, and that would have been fine. What you don't want to do is choose numbers way over here where you're way far away from your axis of symmetry. Stay right around your axis of symmetry. All you're going to do with these numbers is plug them in and evaluate. If you plug 0 there and there, you're just going to get negative 1 as your answer. If you plug 1 in, 2 times 1 squared, 4 times 1, minus 1. Again, use your calculator and do the evaluation if you need to. So 2 times 1 squared plus 4 times 1 minus 1. And I get a y value of 5. So what we're going to do is plot both of those extra points, 0, negative 1, and then 1, 5. And the nice thing about a quadratic is it's always symmetric, so it's a mirror image, meaning that this coordinate point here is 1 unit away from the axis of symmetry on the right, so there'll be another coordinate point that is the same exact distance away on the left. So on the left side, there's also going to be a dot on the left side that's 1 away. Same thing up here. This coordinate is 2 away. So on the left side, there's also going to be a coordinate that's 2 away. Once you have all of your dots, all you're doing is connecting the dots and drawing a U shape. And that's what your graph looks like. The last thing I'll ask you to do on each problem is the domain and range. So if I do the domain, a quadratic is a kind of polynomial, so all real numbers for the domain. Your range, remember you're looking from low to high. The very lowest this gets is a y value of -3. And from there, we go to the sky. So -3 to infinity. What I'm going to have you do is do number 2 on your own. So you may want to pause the video, do number 2 on your own, and then this is something that I will show you the answer to tomorrow. So instead of giving you 5 problems to do on your own at the end, I want you to do this one on your own now, or you can save it until the end of the video. That would also be fine. We are going to switch now to doing vertex form. Vertex form looks like this. This is the form that you should be used to seeing from the last unit when we did transformations. So if I showed you a quadratic that looked like this, you should be able to tell me things like it's skinnier than the original function, that it's moved to the right and it's moved up. So why this is called vertex form is because this number here and this number here tell you the vertex. That's the x-coordinate, that's the y-coordinate. So the first thing that you're going to do is figure out again what the axis of symmetry is. The axis of symmetry is just x equals that number. Now, the only thing I'll tell you is you have to switch the sign of the number when you pull it out of the parenthesis. So since this one was x minus 2, your axis of symmetry would be at +2. If that was at x plus 2, then your axis of symmetry would be at -2. The next thing you're going to do is identify your vertex. Your vertex are just these two numbers. Again, remembering that this one inside the parenthesis you have to change the value of. So that would give me a vertex at 2, 4. You're going to plot more points using an XY table, just like we did with standard form. And you're going to connect the dots and tell me the domain and range. So what we're going to do is number 4 here. It's in vertex form. So the first thing we're going to do is identify what's the axis of symmetry and then what's the vertex. Axis of symmetry is always the opposite of that number. So since it's x minus 2, I'm going to have an axis of symmetry at +2. My vertex change and keep the same. So my vertex is at +2, +3. So axis of symmetry is going to be a dashed line through +2 in this case. Vertex is at 2, +3. So there's my dot. Now things to notice about this one. My a value in the front is negative, which means I should expect my parabola to turn upside down. So what we're going to do is make an XY table. And when we find these values and plot them, I want to keep in mind that my parabola is going to turn upside down. So you can pick values whatever you want as long as you stay near the axis of symmetry. So I'm going to pick numbers like 1 and 0. You could have picked 3 and 4 and you'd be fine doing that also. So again, trusty calculator. So if I plug in a value of 1, what I'd have here is -0.5, because that's 1/2. We're going to do 1 minus 2 squared plus 3. I get 2.5 as my y value. So my first coordinate point is at 1, 2.5. Do the same thing with 0, -0.5. 0 minus 2 squared plus 3. And I get a y value of 1. So all I'm going to do is plot those points. We go right 1 and up 1, 2.5. We go to 0 and we just go up 1. So the nice thing again about a parabola is that it's symmetric. So I have a point here that's 1 away, so I'm going to have a point the same exact distance on the on the right. Here I have a point that's 2 away, so I'm going to have the exact same thing, 2 units on the right. Once I have my coordinates drawn, all we're going to do is connect the dots. And so I have my parabola. This particular one, like we said, should turn upside down, and it does. Last thing, domain and range. Domain for any polynomial, all real numbers. So whether it's quadratic or cubic or quartic or whatever other degree we study in this unit, you're always going to be all real numbers for your domain. Your range is going to change depending on your equation. So from low to high. Low, it's going to go all the way to negative infinity because it's shooting down. And the highest y value we get to is positive 3. And we include that value. So again, I'm going to have you work on this problem here on your own. So either you can stop the video and do it now, or you can come back to it and do it when the video is over. But this problem also you need to attempt, and we'll talk about any issues with it in class tomorrow. Last things we're going to talk about. What if I just gave you an equation and I asked you what's the minimum or maximum value? Now in the last unit I told you the only way that you could determine these things is if you had a graph. That's false when you're talking about a quadratic. Think about this point right here. That is the lowest point on the parabola. This is the highest point on the parabola. What I'm hoping that you notice is that each of those is the vertex of each one of those parabolas. So if you're ever given a quadratic equation and asked what's the min or max value, all you have to do is find the vertex. So that's all this problem is asking you to do, find the vertex. So if I find the vertex here, all I'm going to do is use my nifty equation, negative b over 2a, because this equation is in standard form. So what I would have is the opposite of b, which would be positive 12, 2 times a, so 2 times negative 3. And I have a fraction of 12 over negative 6, which is an x value of negative 2. So what that gives me is the x coordinate of the max or min value. I need to take that and plug it in to figure out what the y coordinate is. So, trusty calculator, let's plug it in. Negative 3 times negative 2 squared minus 12 times negative 2, add 10. Push enter, and my y coordinate comes out as 22. So the problem wants to know what the maximum value is, or what the minimum value is. That value is just the y coordinate. Now, last thing that you need to realize is that this particular function turns upside down. It would look like this if you graphed it, because I have a negative in the front, which means that I have a very high point. So this has a maximum value. So that maximum value would just be 22. Again, this problem here, I want you to try on your own. So you're going to figure out, does it have a maximum or a minimum? And then you're going to find it. So all you're asked to do is find the vertex. The last things we're going to talk about are these two word problems. And I know what you're probably thinking is that, oh my gosh, I can't do word problems. But these word problems are actually pretty basic. So the first thing that we're going to notice here is that we are given an equation and we're asked what's the maximum height of the ball. Anytime you're asked this, maximum, all you're being asked for in a quadratic is the vertex. So if I know that that's the equation, all you have to know how to do is find the vertex. So if I can find the vertex of this quadratic, I will answer the question in letter A. And all you're going to do is use your little nifty equation, x equals negative b over 2a. So your negative b would be the opposite of 50, so negative 50. And then 2a would be 2 times negative 16. So you get negative 50 over negative 32. So let's see what the calculator says. Oops. The answer would be. And the x value comes out 1.5625. Okay, now is that the answer for the question? No. The answer for the question comes from taking that number and plugging it into the equation. So we're going to figure out that the height is negative 16 times that number squared plus 50 times that decimal value, plus 4. That's going to give you the maximum height. Now, yes, that decimal is a little gross, but again, trusty calculator. All we're going to do is evaluate using the calculator. So as long as I can type numbers into the calculator, this shouldn't be too scary. And by doing that, I get a value of 43.1-ish. So this ball is going to go about 43.1 feet in the air. That's the maximum height it's going to go. After it gets to that height, it's going to start falling again. How long would it take to reach that height? That's the answer that we found in letter A. That's the x equals. That's the time it takes. It takes 1.5625 seconds. The x-coordinate tells you how long. The y-coordinate tells you how high. The last question then here is how long does it take for the ball to hit the ground? So if the ball is on the ground, that means that the height of the ball would be 0. So you're going to take out that h and plug in 0. And all you're doing is solving the equation. If you're solving a quadratic equation equal to 0, you know or have learned 4 different methods to do it. I can tell you in a real life problem like this, the easiest way is probably going to be just to go straight to quadratic formula. So that's what I'm going to do. Opposite of b would be negative 50, plus and minus the square root. 50 squared minus 4ac all over 2 times a. As long as you plug all the numbers in, all you have to do now is do a little bit of evaluation, and that's going to give you the times. So let's do that. The first thing we're going to do is make sure we type this in correctly. So negative 50 plus the square root, 50 squared, minus 4 times negative 16 times 4. Close that parenthesis. That's the numerator. Divide by the denominator, which would be negative 32, and I get a negative time. So one of my values is negative 0.078. What we're going to do is the exact same thing, except we're going to do it with the minus sign in front of the root instead. Divide by negative 32, and did I type something in wrong? Ooh, that takes a long time. Okay, so this gives you a really big number, which if that's in seconds, that's going to be over a minute it takes to get to that height. The numbers in this equation aren't going to be exactly perfect, it doesn't look like. So we're going to take this answer with a little bit of a grain of salt unless I can figure out that maybe I typed something. Oh, I did type something in wrong. When I did this here, notice I forgot the plus sign in the front. That's why it looks a little weird. That's why the number came out so big. So let me retype this so that we can get the right answer, because this is not the right answer. So let me retype with the plus sign now in front instead. I accidentally did it to where it was multiplying. So that's supposed to be a minus sign, not a plus sign. Shoot. I already did the plus sign one, didn't I? All right, I swear I'm going to get this right this time. That's more reasonable. So typing it in correctly, first off, is going to give me 3.20 seconds, it looks like. So you may ask yourself, what does it mean that I got a negative? That means that you'd be going back in time, so we're not going to accept that answer. And we're going to say that it took 3.2 seconds to hit the ground. I've got some problems to assign to you in your in-class that are like this. So if you have questions on those problems, just make sure you ask. The last problem, number 8 down here, this go-kart problem, we're going to talk about this in class because you actually have to come up with the equation yourself. And so I want to kind of lead that discussion during class so that you have a chance to ask questions about when we're coming up with that equation. So if there's anything else, anything from the graphs or finding the vertex or anything like that that you want me to go back over, make sure that you make a little list of questions so that I can answer them in class.